these were just using right triangle trig. If it's helpful, you could put this on an axis, or, quadrant 1, if you rather use the X, Y, and R. This is your basic SOHCAHTOA here. Without any axes. If you wanted to put it on an axis, put it in quadrant 1. This is your Y, X, find your R, you're missing, or you had to find your X this time, sorry. Find your X, your missing piece, and set it up. I would almost rather you did an X, Y, and R to get used to it. Everybody okay with finding the missing sides? This is kind of like maybe 8th, 9th grade stuff. We just find the missing piece, find your functions, reduce to lowest terms. These are your triples. These are your triples, the ones that come out with whole numbers. Your missing side, all I would say is be careful which piece you're missing. This year we're missing a leg. This year we're missing a hypotenuse. And again, you can put this on in your quadrant 1. So there's your Y, there's your X, and you just found your R. There's one of your triples. And Y over R, X over R, same thing. Stop me if you have any questions. I'm just going to assume these didn't go so badly. Number 11. Number 11 was a multiple of your 3, 4, 5. It's a 6, 8, 10. So if you wanted to, you could reduce it here. You could reduce it to your 3, 4, 5. And then work it that way. Then even if you wanted to put this on a coordinate plane, X is equal to 4, Y is equal to 3, R is equal to 5. And reduce it from there. Actually, these two triangles are both multiples of a 3, 4, 5. This triangle is half. 2 is half of 4, 1.5 is half of 3, 2.5 is half of 5. They're all going to work off of this 3, 4, 5 triangle. If you use the 1.5 and the 2.5, you're going to get the ones with the decimals. We really don't leave decimals in your fractions, but if you did it because that's what it came out to be, that's fine. Trig ratios are just that. They are fractions. They're ratios side to side. Try not to take them and reduce them. Yes, your calculator gives you a 4 decimal place or, a more infinite decimal place. It's irrational numbers. But did you spot that these were the same 3, 4, 5? That's helpful. You only really have to do it once. These are your similar triangles at work. Okay. Number 13. Again, this is not one of your specials. So you do Pythagorean theorem. You're going to have to leave this in radical form. Make sure it's lowest radical form. Most reduced. You don't have to rationalize denominators, so that's nice. If you put it in your quadrant, which is probably a little bit better, X is equal to radical 11, Y is equal to 5, R is equal to 6. Everybody's good with this? If I gave you a quiz on this now, it would be good? So what would not be good? I'm just asking you to find one extra side of your right triangle, Pythagorean theorem, and then apply your functions. SOHCAHTOA or XYRs, do those. Good?
That's easy.
This is easy.
I haven't memorized the trig function.
The trig, you didn't or you did? So, did you catch my little trick with the SOHCAHTOA thing? Did you remember this one? Do you know that one? Yes, and we're going to change it to the X, Y. Do you know that one, though? I'm not going to record me saying this. Sonics make make life very easy to remember things. Very easy to remember a mnemonic. The one with the planets. My very excellent mother just served us 9 pizzas, whatever those were, but now we have no more Pluto, so she just served us 9 whatevers. So find a way and memorize them. These guys, we gave you a function, and then you put it out in your, you can do it without a quadrant or with a quadrant. If you don't like using the reciprocals, use the reciprocal of this, cosine, and take the reciprocal of this, if you like looking at the cosine. It's the same as above, only you just had to lay this out. So in this case, x is 1, y I had to find, and r is 4. And do the y over r, you can do opposite over adjacent, whichever one you decided to do for this. It was just a triangle. I like to put it on the xy axis, but you didn't have to if you didn't want to. This is your y, your x, your r. And again, just make sure you reduce to lowest terms. Tangent, put it over 1. Trait is a ratio. Put it over 1. Y to x. Find the missing piece, Pythagorean theorem. And set it up again, x, y, r. Whether you use opposite adjacent hypotenuse or x, y, r, you're going to get the same answer. I'm an x, y, r person, and I like you to flip to that, but you know, whatever you find more comfortable. If they don't tell you, put it on the x, y axis. This one works the same way. We gave you a cotangent. You had to find the missing pieces. Now 67, you had to find me the angle. The direction said find the angle between 0 and 90 degrees, which puts you in what quadrant? 1. And find it between 0 and pi over 2, which is the same thing as this one, but this one I wanted radians, that's all. So when you come here, you've got a function. Your sine is y over r. Set it up. Find your missing part, Pythagorean theorem. Or, because these are your special right triangles, you should recognize the 1 and the 2. This is a 30, that's a 90. Oh, there's your 60. So this is a 30-degree special triangle. 30 degrees, 30 goes into 186 times. There's your pi over 6. On the next one, if you don't like to look at a cosecant, flip it to a sine. Flip this over. Ah, this is the same as this one, isn't it? Maybe the cosecant wasn't easy to recognize until you laid out your triangle. Can everybody find those angles in quadrant 1? You just had to find the positive angle, the acute angle. And these are your special right triangles. Secant, again, if you want to flip this to cosine, 1 over 2, x over r. If you remember r over x, whichever one you want to set it up as, that was another special right triangle. Find the angle, divide the angle into 180, flip it to radians. Cotangent and a tangent are the exact same. And when it's 1, that means your sides are the same, right? 45, 45. 71 and 71A and B are harder to recognize because they've already been rationalized. So sometimes what's easier is to unrationalize them, if you will. I started out like this and multiplied top and bottom by radical 3. This is what's going to lead you to your special triangle. This might not. But once you set this up, if I set this up to say 3 is over here, this is my r over y, so this is this piece. It might not be as easy to find for your special right triangle because normally opposite to 60, that has the radical. But this time, it's the other two pieces that are going to have the radical. So it might not be as easy to see. So unrationalize that. It will look a little bit easier. And this one you might just remember radical 2 over 2 for your sine and cosine of 45, right? Do you kind of remember that from trig? We always went with the rationalized radical 2 over 2. That was automatic. 45. Unrationalize that. That probably would be easier. Okay. Any questions for these? Sound good? So, where is cosine positive? What quadrant? First and the fourth, wherever x is positive. Where is sine negative? 3 and 4, wherever the y is negative, and they overlap here. Quadrant 4. Good. Those were great 2-point questions. A 100-foot line is attached to a kite. When the kite is pulled taut, the angle of elevation to the kite is approximately 50 degrees. Find the height of the kite to the nearest hundredth of a foot. Now, when you fly a kite, does it sit exactly over you? No, it's at a slant, right? So, start with that. Here you are. You're flying the kite. Here's your kite. It's pulled taut. What is pulled taut? Your line, right? How long is that line? 100 feet. Okay? Now, we want to find the height of the kite. Height makes the H. How high off the ground is that kite? That I don't know. My angle of elevation is from your line of sight to the top of the kite. This is your angle of elevation. This is 50. So, basic right triangle trig. There's no law of cosines, no law of sines. Basic right triangle. So what function should I use? Sine, tangent, cosine. Sine, I have an opposite and I have a hypotenuse. So I say the sine of 50 is equal to x over 100. And cross multiply. Another thing, watch the parentheses here. It's okay this way, but if you do this, you have to make sure you close off that parentheses because they give you one for your trig functions, but then you got to close it off. And do all your calculations at the last step. So to the hundredths of a foot, what do you get? Good. And see if that makes sense. You have a right triangle, which, you have a right triangle, which the hypotenuse has to be the biggest side. So make sure that that part is not larger than the hypotenuse, right? That's one good way to check. Everybody okay with that? All right. This next one I took from a Regents. See if you can read this and set it up. Take a look at your diagram. You have a building. You're at, from the base of the building, a point 200 feet away. Here you are, 200 feet away. And you're looking up at the bottom of the smokestack. So here's a smokestack on your building. You're looking up to look at the bottom of the smokestack, which is the top of your building. Your building makes a right angle to the ground. Okay? And your angle of elevation from the bottom of the smokestack to the bottom, from the floor, from the ground to the bottom of the smokestack is 35 degrees. Now, you don't move. You just elevate your eyes a little bit higher to look at the top of the smokestack. You stay here, you look at the top of the smokestack. From here to here, your angle of elevation increases to 53 degrees. We want to know the height of the smokestack. I want to know the height of the smokestack. let's call this S. They called it S. Let's call it S. The height of the smokestack. Now, how many right triangles do you see? 2. I see one here, which will give me the height of my building. Let's call this X, the height of my building. And I see another one here, which will give me the height of my building plus the height of my smokestack. Let's call this height Y. How, if I know Y and I know X, how can I find S? Subtract them. So our goal is to do Y minus X. These are both right triangles. If you need to, take them apart. I've got one that has a 35 and X. They both share the same base. What function will I use to find the side here, the height? Opposite and adjacent. Tangent. So I've got the tangent to find X. I have the tangent of 35 is the opposite over the adjacent. I'm going to just cross multiply, but don't put it in your calculator yet. Now I'm going to do the same for Y. I have another triangle. This is the big height Y and an angle of 53, and it shares the same base. So again, I've got the tangent of 53 equals Y over 200. I cross multiply. And now I know what Y is equal to. So all I have to do is subtract the Y value, 200, tangent of 53, minus the X value. Do all your calculations at the end. And make sure your your mode is degrees. This will give you the height of your smokestack. And to the tenths, you should come out with 125.4 feet. It's a pretty high smokestack. Looks a little different than my picture, I realize. You have a nicer picture. It's showing this a little further apart, and it's actually showing the distance, which is not drawn to scale, by the way. Here's your center. It's coming out here. Here's your right angle over here. This piece over here is 150 miles. This piece was 4,000 miles, not drawn to scale. And here's your angle of depression. Here's your horizon or something, and here's your angle of depression. Technically, your angle of depression should have been on the other side. I don't know why this looked like this, but your angle of depression should have been over here, but they put it over here. This angle of depression is the same as this angle of elevation. Your parallel lines cut by a transversal. So that angle of depression could be the same as this guy over here. And your angle of depression is what you had to find. Now, the other thing too is, if this is 4,000, this can't be 150. So this is 4,000 here, plus 150. So this hypotenuse is 4,000 plus 150. So you're basically looking at a right triangle. We want to find this angle. We know this is 4,000, and we know this is 4,150. So what function are we using? Cosine. I drew mine a little bit different, but that wasn't the one that I put on here. Mine I drew a little bit more to scale, because I didn't like theirs either. But cosine, we don't know the angle, is the adjacent over the hypotenuse. Now, how do you find an angle given the two sides? In your calc, how do you find that angle? Given the ratio. Second cosine, this is its inverse, and find me the angle to the nearest tenth of a degree. I don't know why that was crossed out. Anybody find an angle? Good. 15.5, make sure you put degrees. Okay. And one more. This one's a good one too. I want to find an angle in quadrant 2 that falls on this line, y equals negative x. And I want to find all the values for this. Where is the line y equals negative x? It's this way. And what do we know about that line? It cuts through that quadrant in half, right? Because whatever my y is, my x is, like if my x is negative 3, my y is positive 3. If my x is negative 4, my y is positive 4. It's equal. So if you wanted to, and you wanted to drop a triangle, and this went out to negative 4, then this also has to be 4, right? It has to be the same size, doesn't it? What angle is this guy? 45. So if you wanted to keep life simple, once you realize it's a 45, you can just label 1, 1, radical 2. X over here is negative, that's where the negative comes from. Y is positive, and your R is radical 2. Can you do all your trig functions off of that? Mm-hmm. You see what we did? Well, and you can also look at it differently. You can look at your slope as y over x. You're changing y over the change in x. You can look at your slope that way. So if my slope is negative 1, I could say that this is the change in y over the change in x. That will give me a 1 over a negative 1. And do my slope that way. If you want to look at it like that. So tonight, you have all the applications to do.